Hey, what's up guys? In this video we're going to take a look at some examples of how we can factor a sum of perfect cubes. Alright, here it is. Hey guys, so the first thing I want to talk about is what is a sum of cubes in the first place. So a sum refers to anything that's being added together. So here we have a plus sign, we have one quantity here plus another, so we have a sum. And what makes something a perfect cube is if you can express that value as something raised to the third power. So a to the third is a perfect cube, and b to the third is a perfect cube, and we're adding them together, so we have a sum of cubes. And when you have an expression like this, you can factor it. You can write it in a factored form where you have the binomial a plus b times the trinomial a squared minus ab plus b squared. And so in our first example, the first thing we're going to do is make sure that we have a sum of cubes in the first place, and then we'll go ahead and factor it. So in this case here off to the side, I'm going to write the fact that we have a to the third is x to the third in this case. Alright, and in order to factor this, we need to know what a and b are. We don't need to know what a to the third is, we need to know what a is. So if a to the third is x to the third, well then that would mean a has to be x in this case, okay? Because you can just take the cube root of both sides here to get a by itself, and the cube root of x to the third is just x. So we have a, and now we need to figure out what b is. Well, b to the third is 8 in this case, but we need to know what b is. So again, we're going to take the cube root of both sides here. And so you have to think to yourself, what times itself, then times itself again would give you 8, and the answer to that is 2, because 2 times 2 times 2 is 8. Okay, so now we know what a and b are, x and 2 respectively, so we can go ahead and factor this sum of cubes. So we start with the binomial a plus b. Well, we already know what a and b are, so that's x plus 2. Alright, and now we have this trinomial to work on, where we have a squared. So again, we know a is x, so a squared in this case would be x squared. And then we have minus a times b. Well, a times b would be x times 2, or in other words 2x. So we can keep in mind there's a subtraction here, so it's minus 2x. And then plus b squared, and b again is 2, so b squared would be 4, so plus 4. So really all you need to do for these is figure out what a and b are, and then you just go ahead and make your substitutions into the factored form here. So if you want to double check this, you could always do the distributive property, right? Distribute your x through, and then distribute your 2 through, and then verify that you do end up with x cubed plus 8 in the end. Alright, so we'll do a couple more. And keep in mind, these are fairly simple examples. I'll probably do another video that are a bit more complicated. Alright, so here we have something like 27x cubed plus 1. So again, it's just to know what we're looking at, it's good to verify that this is a sum of cubes in the first place. So I see my plus sign, so I know it's a sum. I know 1 is a cube because 1 times 1 times 1 is 1, so that's 1 is a perfect cube. And 27x to the third is also a perfect cube because, I'll actually write this out here. So remember again, this is a to the third right here. So a to the third equals 27x to the third. Well, we need to know what a is. Remember, we need to figure out what a is. So by taking the cube root of both sides, you have to think to what times itself again gives us 27x squared? And the answer to that is going to be 3x. Because 3x times 3x is 9x squared, and then 9x squared times another 3x is going to be 27x to the third. So we know what a is, and then b to the third is 1. And that means that b is also 1. Because taking the cube root of 1, we end up with 1. So we know what a and b are, and now we can go ahead and factor. So we start with the binomial a plus b, so that's going to be 3x plus 1. And now we're going to write out our trinomial a squared. Well, if a is 3x, then 3x times 3x is going to be 9x squared. And then we have minus a times b. Well, a is 3x and b is 1, so a times b is just going to be 3x times 1, which is 3x. So we have minus 3x. And then plus b squared. Well, b is just 1, so b squared is 1 times 1, and that is going to be 1. And there is your factored form. Okay. And we will do one more here. This one I'm going to write out a bit more explicitly, just to be perfectly clear. So here we have 27x cubed plus 64y cubed. So the first thing we're going to do is figure out what a and b are. So a cubed is 27x cubed, and we actually know what this is, we just did this one. So a is going to be 3x, and then b cubed is going to be 64y cubed. And so what would b have to be? And in this case that's going to be 4y, because 4 times 4 times 4 is 64, and y times y times y is y cubed. So 4y times itself and then times itself again will give me the 64y cubed. Okay. Now we're going to factor this out a bit more explicitly. So a plus b, that's going to be 3x plus 4y. Okay. Now a squared. So I'm going to just go ahead and make a substitution here just to be clear about what's happening. Okay, so there's a, 3x, and then I'm squaring it, and then we'll simplify that later. Minus a times b, so a times b. Oh, I accidentally wrote b first, but that's fine. Okay, and then plus b squared. Okay, again, b was 4y. And now I'll just go ahead and simplify this just so you can see exactly what's happening. There's my binomial still. Now 3x squared is going to be 9x, 3x, the quantity squared, is going to be 9x squared. And then we can multiply the 4 and 3 together, so that's going to be minus 12xy, or yx, doesn't matter. And then 4y, the quantity squared, is going to be 16y squared. And there is your factored sum of cubes. Okay, I'm going to make another video with some more complicated examples where there might be another step involved after this one where you can continue to factor these. But I'll save that for the next one. Alright, with that said, it's been demonstrated.